Okay, so today I want to record the solution to the group vector problem. In the group vector problem, it has vector A being 6.1 meters long and 21 degrees above the x-axis. And I always like to start by drawing the situation. So let me go to red for vector A. 6.1 meters long, 21 degrees above the plus x-axis. So plus x and plus y are like that. So it's going to be something like this. So 21 degrees there, 6.1 meters long, there's my vector A. Okay, vector B is 4.7 meters long and it's 37 degrees clockwise from the minus y-axis. Let me go to blue for vector B. So minus y is down at the bottom. So I'm saying I'm going to go 37 degrees clockwise from that. So clock goes around in this direction. So let's say something like this is 37 degrees. And it's 4.7 meters long, so I'll draw it a little bit shorter than I did vector A. All right, so there's my vectors. Now I want to find the magnitude and the direction of the vector C, which is the sum of A and B. And it tells me to sketch all the vectors and label the relevant angles, so I've done that for A and B. And then write the vectors in component form using the unit vectors. So when I'm going to add these vectors, I'm going to add them by component. So I need to break the vectors into components. So vector A, I can break into a horizontal component, AX, and a vertical component, AY. So let me go over here. AX is equal to, and if I look at it, A is the length of that vector, so that's my hypotenuse. The X component is touching the angle adjacent to the 21 degree angle. So AX is equal to cosine. So A cosine theta. So that's going to be A is 6.1 cosine angle of 21. And I'm going to get 5.695. And I'm going to leave a whole bunch of significant figures right now. So in my problem, I've only got 2 significant figures in the length and 2 in the angle. So at the very end, I need to round off to 2 significant figures. But while I'm doing the problem, I'm going to leave it as many as at least 4, or as many as my calculator gives me if it's less than 4. All right, what's the vertical component? So vertical component is this side over here, which is opposite to the 21 degree angle, so that's sine. So it's going to be A sine theta. So that's going to be 6.1 sine 21, which is 2.186. And of course, those lengths are meters. So if I want to write that vector in component form, I'd write vector A is equal to AX I hat plus AY j hat. So 5.695 I hat plus 2.186 j hat. Remember, I hat just means in the x direction and j hat means in the y direction. And I'll put meters so I know the units. All right, let's do the same thing for vector B. And let's see it. Let me go to blue writing. So for B, the x component now is the horizontal side. So that's BX. The vertical side is BY. And so if we look at this, we can see BY is going down in the minus y direction. So I need to make BY negative. BX is still going in the plus x direction, so I'm going to make it positive. All right, so BX. Now if I look at BX, that side is opposite to the angle, so that's going to be sine. So it's going to be the length of B, 4.7, sine of 37, which is 2.8285. I'm going to keep a bunch of digits again, meters again. BY, remember we said that one had to be negative. Let me put a minus sign in front. B. Now if I know one is sine, the other one's going to be cosine, but let's just look at it. So BY is touching the angle, touching that 37 degree angle, so it's adjacent. So that's cosine. And so that's minus 3.7536 meters. So I can go ahead and write that vector B in component form as BX I hat, so 2.8285 I hat minus 3.7536 j hat. And I guess if this were my final answer, I should round that to two significant figures. So I should say 2.8 I hat minus 3 let's see, that 7.5 is going to be rounded up. 3.8 j hat meters. All right, so there's my vectors in component form for A and B. Now I got to do vector C. All right, so to get vector C, I need to add up. So C, and let me do that. Let's do C in green, just so we can keep track of everything. So let's say C is equal to A plus B. So we know we add the components. So Cx is equal to AX plus BX. And CY is equal to AY plus BY. So now all I got to do is go up and pull out my number. So AX was 5.695. BX was 2.8285. I kept a different number of significant figures for the two, so it's a little bit bad. But let's just keep rolling with it. So 8.5235. And of course that's meters. CY is AY plus BY. So AY is 2.186 meters from up here. BY is negative, so minus 3.7536. And so I'm going to get a negative CY. 1.5676 meters. Okay, so if I write vector C in component form, it's going to be to two significant figures, 8.5 in the x direction, so I hat, minus 1.6 in the y direction, so j hat meters. All right, so last thing we have to do is I want to find the length of vector C and the angle that vector C is at. And so what I always do is draw a picture. All right, so there's my coordinate system. So Cx, so this tells me I'm going to go 8.5235 in the x direction. And let me go back. I'm going to make the coordinate system in black so you can see what I'm doing. So let's go back to black there. Then I'll draw my green on top. So I'm going to go 8.5235 in the x direction. And then I'm going to go minus 1.5676. So something like that. It's not perfect. In the y direction. So my vector C goes across like this from the origin to where that CY ended up. So there's my vector C. So if I want to find the length of it, that's the hypotenuse. So the hypotenuse is a squared plus b squared. So cx squared plus cy squared. So throw in my numbers now. So again, this is why I keep significant figures. So if I had just squared 8.5, I will get actually quite a different number to 8.5235 squared. And cy is negative, but remember when you square a negative number, you get a positive number. So my C comes out to be 8.666, and now I got to round that to 8.7 meters. So the length of vector C is 8.7 meters. The angle, now the angle is in there. So to get the angle, what we do is we do the tan, which is opposite over adjacent. So tan theta is opposite, which is the 1.5676, and put that in as negative, divided by adjacent, 8.5235. Throw that in your calculator, and you get that that ratio is negative 0.1839. Then to get the angle, you have to do the inverse tan. So it's inverse tan of negative 0.1839. And so I get negative 10.4 degrees. All right, so often you'll write that as 10.4 degrees below the plus x direction. If you're putting your number in on Mastering Physics, it asks you to give a number between 0 and plus 180. If it's in quadrant 1, it would be between 0 and plus 90. If it's in quadrant 2, it'll be between 90 and 180. And then if you're below the axis, you're going to go from 0 to negative 90 in quadrant 4, And in this quadrant, it's going to be between minus 90 to minus 180. All right, so in mastering, it asks you to give a number between plus 180 and minus 180. So then you would just put your number in as minus 10.4 degrees. Okay, so that's how you're going to do the vector problem. And let me see if I can get the recording to stop.